Finally, we're going to take a quick look at correlation tables and straightening scatter plots. So correlation tables, if you look at some research, frequently you'll see tables that correlate one variable to another. And so they'll look at all these different things that could affect each other. For example, here they're looking at reading, writing, math scores, and science scores, and then whether female, although, technically isn't that a category, but we won't worry about that right now. So anyways, you'll notice that on the diagonal here, we've got a 1 on the correlation, which makes sense. Reading should correlate perfectly with reading. Writing should correlate with writing. Now, if you look at writing to reading, it has a score, has a correlation of 0.597. If you look at reading to writing, it has exactly the same. So typically when you're looking at one of these tables, it might be missing the part above the diagonal because that's just the mirror of the other correlations. Now, it is a quick way so you can say, hey, where am I seeing the highest correlations? Maybe I should check that out. The disadvantage, though, it's very risky because, one, it's assuming linearity because that's what correlation assumes. And secondly, outliers could be influencing R, the coefficient of correlation. For example, you've got these two images right here, and if I circle these outliers, you can see that this is really pretty random here, and I have that one point that's an outlier that's kind of making it look linear. Whereas here, I can actually definitely see a pattern right here, but this one point, if you look at it, it's really making it look like a scatter plot, and it's nonlinear, so correlation is not very helpful here. The last topic we're going to be covering is re-expressing data. So sometimes, remember when we dealt with like earthquakes or taking the log or the square root, there were ways to work with the data so you could see the pattern better. And the same thing applies to correlation. If we're able to straighten out the data, then we can actually do some correlation to the new expression of data. So the first thing you'll do is create a list for year. So I'm looking at problem 37.6 on page 167, and I'm creating a list for year and also journals. And one thing when you're creating the list, if you want to put a new one, you press second insert to insert a column or rename one. You can also press delete when you're at the top there for those column names, and the entire list should go away if it's not L1 or L2. Once you've created your list, you want to graph the scatter plot and make sure that you have the X list and the Y list appropriate. And actually I have some old data there, so let me make sure I put in year and then put in journal for the Y list. So put in the correct list there. Okay. And when I hit graph, you're going to see the graph of the new scatter plot. And I'll probably have to hit zoom stat, which is zoom 9. We're starting to learn. And you can see it's not very linear. So what can we do? Well, we can go back and take a look at this data. We're going to take the log of it. So I'm going to create a new list by pressing second insert. And I'm going to call this list log of journal, LJUR. And then basically right here, you see that equation part. I can actually say equals something. So let me get back in there and hit log. And then I can go second list name to take the log of journal, right? And I just pick that. Make sure you close your parentheses, hit enter. And it's now created a new list of the log of the journal year. Now I modify my new scatter plot. Instead of journal, I'm going to have second list and go to log of journal, enter. And then I should be able to just hit graph to see the new plot. It doesn't look right because I took the log, so everything's smaller. And now you can see it's much more linear. Now I can go back now, since it looks more linear, I can calculate the correlation. So make sure I hit stat calc and line reg, AX plus B. Oops, I had the wrong writing down here, ignore that. And make sure you have your X and your Y. So it's year, comma, and L journal. So don't use journal, use L journal because that's the one that's more linear. Okay. And when you see it, you can see the very strong correlation coefficient. So in this example, we could see initially with the original data, we had a very curved pattern. There was definitely a pattern. There's definitely an association. It's just not linear. So we take the logarithm of the data, creating a new list, and you can see when we run the correlation, it's very strong at 0.98. One more problem for you to try on your own. Try problem 35 on page 166 and check your answers against the back of the book.